All right, let's get started. So good morning, everybody. Welcome to our webinar series hosted by Enercon Engineering's Integrated Defense Solutions Business Unit, or IDS for short. I see I have some returning viewers, so thank you guys again for your continued support and joining us this morning. And we do have some new viewers. So for our new viewers, if you don't know, Enercon is your power integration solutions expert. Our main facility is located in East Peoria, Illinois. That is where we do all our designs, manufacturing, and testing. We have produced over 40,000 projects, not only domestically, but all around the world in 110 different countries. I'm your host, Sean Lott. I'm the Director of Business Development. I am located in the Business Development Office for Enercon IDS in Huntsville, Alabama. This is our 6th webinar in our 2020 series. If you missed any of our previous webinars, just visit our YouTube page. If you go to our YouTube page, you can see all of our webinars that we've done the entire year, as well as other Enercon informative videos highlighting our 45-year history. When you get there, all you got to do is search for Enercon Engineering in the YouTube search bar, and then you'll see all the Enercon stuff pop up on the page there. And feel free to search around and look at all the videos that you shared up to look at. Some of them are informative and discussion type videos like this webinar. Other ones are just kind of pump you up style videos that's showing what it is that we do in 90 seconds or so. An easier way to do it, I've just dropped in the chat box, is the link to the YouTube page. So you can just click that link as well and it'll take you directly to it. Before we get started, I just want to let you know that if you have any questions, they'll be answered at the end. There's a Q&A tab that you see on your screen. You just click that Q&A tab. You type in the question that you want to ask our presenter, Steve, and we'll get those answered at the end of the session. I also want to know, don't be bashful about asking your questions because nobody knows who asked what questions, because I'm not going to read your name or anything like that. So no question is a dumb question, so feel free to ask anything you would like to, and Steve will definitely get you the answer based off of his experience and his resume. Also, as a reminder, this session is being recorded for on-demand viewing. You can see us, we can't see you, but we do know that you're there, and we'll post this on Facebook, and we will also post this on YouTube for people that missed it or for folks that want to share this video. So with that, let's get to today's presenter. We are excited to have Steve. So I want to introduce to you Steve Conrad. Steve is from Springfield, Illinois. He attended DeVry Technology in the late 60s. He worked for companies like Sangamo and Simplex. At Simplex, Steve has had his first exposure to power generations and controls, where he manufactured control panels, voltage regulators, diesel fuel, day tanks, and switchgear from 1972 to 1977. Steve worked for a cat dealer for 3 years in Kentucky before joining Enercon in 1981 as a testing technician. He then went on to be a field technician. He has worked for Enercon in over 47 various countries around the globe as a field technician. He's also did project design engineering, and he's also was an engineering manager, and he's currently a senior applications engineer. Steve retired from Enercon in 2013, but he still provides his part-time expertise to the Enercon family. To date, Steve has 39 years with Enercon, which makes him the 3rd most tenured employee in Enercon. So what a treasure. So with that, Steve, welcome, and the floor is yours.
All right, thank you, Sean. Appreciate it, and welcome everybody. This presentation that we're putting on is about retrofitting switchgear and controls. If it isn't broke, don't fix it. I'm sure we've all heard that many, many times. So why would we want to retrofit or upgrade switchgear controls that, hey, they work fine as that was originally designed? Well, what we're running into these days is component obsolescence. And we find due to the current technology, technology seems to increase exponentially, which causes these older components to be obsolete. And then we also need to compare total cost of replacement of the entire switchgear and controls, or just retrofitting the controls and the upgrade cost of doing that. And then I'm going to touch a little bit about sequence of operations. I want to mention a few things about the drawings that has to take place during this retrofit upgrade process. And then we're going to go through a step-by-step process of how we retrofit switchgear and controls. Okay. The obsolete components that we're finding these days, simple things like indicating lamps, those are conventional filament type that have bulbs. Bulbs burn out. So we're getting away from those. You're seeing more and more LED type indicators and things like that. Analog meters are kind of going by the wayside. And even some of the older digital meters, they were single function meters. Where technology is getting away from that. We're going to multi-function devices. Single function protective relays. The older protective relays, if you had, say, a generator that needed 7 protective functions, those were single function relays. So you'd have individual relays for each of those functions. Of course, back then, protective relays didn't have communications. They didn't have readouts. And these relays, you can't buy them anymore. You can't find them. So another reason to consider upgrading. Communication protocols change. Some of the PLC manufacturers used to have proprietary protocols. And a lot of that has changed. For example, Ethernet. Ethernet's probably the most common protocol that's used these days. And some of the older protocols, you can't communicate with some of these older devices. A lot of the PLCs that are obsolete, you can't buy them. You're certainly not going to get any factory support. Because they don't make them anymore. Operator interfaces. We first started using PLCs back in the 80s, and operator interfaces consisted back then generally of just a numeric keypad, a small little readout that you could get in and change timer settings and things like that, and those are obsolete. Governors and associated components. An engine generally always had a hydromechanical actuator. You had a lot of associated components that went along with the governor control. You had automatic synchronizers, you had loading controls, you had import-export controllers, you had all these individual components. Now, these are all integrated into a single device. A generator control module, which we have some illustrations later. Same with voltage regulators. You take a generator and you parallel it with utility, for example. You needed a power factor controller. You may have other associated components, remote raise lower potentiometers, things like that. Today, these are all integrated. The voltage regulators today, they pretty much have all these components that used to be individual. These are all integrated into the single regulator these days. That's the current technology. Okay. The benefits of the current technology. You're definitely going to have improved reliability. If you have any component failures, at least you're going to be able to get it. because it's current. Increased and integrated functionality, as I just mentioned, protective relays and things like that. These are all integrated into multi-function devices now. So that means less components that's required, which less wiring, fewer connections, fewer points of failure, which that's going to increase the reliability of it. We use current communications, as mentioned earlier, Ethernet. We use current PLCs because that means that if they're current, we can get factory support from them if need be. So big benefits of retrofitting up to current technology components. Okay. Now, this is what I mentioned earlier about the sequence of operation, and this probably would apply more to when we do retrofits with other manufacturers' equipment. We not only can upgrade and retrofit equipment that's manufactured by our company, but we also do retrofits and upgrades to other manufacturers. Some of the manufacturers that have gone out of business, for example, we can retrofit and upgrade those systems as well. But it's very, very important to know exactly how the system is going to operate. How does it currently operate? And some of these systems are very complicated, especially when you get into main tie main. Some of the systems are multiple main type main sequence of operations. We do a lot of generator paralleling with utilities and load control and things like that. So we definitely have to be sure that we understand exactly how it operates. We would prefer to have the customer provide us with an actual step-by-step sequence of operation if it's available. I know presently we're doing a retrofit project out in Arizona, and the sequence of operation was on these placards that was attached to the front of the gear, and the customer basically he took pictures and sent us the pictures, which that was the sequence of operation, which is what we need. And sometimes the sequence of operation may be changed during the retrofit process. They may want to maybe change the way that it operates, which we can incorporate that into our design. Okay. What about the drawings? As I mentioned, this is another very important part of the retrofit. And this, again, probably applies more so to other manufacturers' equipment. But we do need original drawings. And are they up to date? We do from time to time run into situations where the original control system may have been modified, and it may not have been documented properly. And the best thing is, obviously, can we get the drawings in AutoCAD format? That makes it much easier for us to change the drawings. And again, has the system been modified or changed? And if so, has the documentation been done properly? It's very, very important to understand this. Okay. This is the step-by-step process that I mentioned. This is what we have to do to essentially start to finish. We need to discuss with a customer how he wants to retrofit and upgrade his controls. If it's other manufacturers' equipment that we're going to retrofit and upgrade, a site walkthrough, if possible. That's the best thing. And pictures, they're worth 1,000 words, and that's very true. A lot of times we'll have a customer if it's not possible to do a walkthrough, we've had customers that have taken pictures, just a tremendous amount of pictures, even, to the point of taking a tape measure and taking a picture to see where a door hinge is located, or what's the dimensions of the sub pan, which is primarily when we retrofit and upgrade controls. That's pretty much what we replace doors and we replace sub pans, and we have to be sure that everything fits when it gets out to the site. Another important thing is to coordinate with the genset dealer or the customer if the engines are being upgraded. And we're finding this more and more happening. Not only do they upgrade the controls, but they also will upgrade at the same time the engine. We're doing a project right now at a major pharmaceutical. We're totally upgrading the controls, but they've got a service provider out there. They're going to totally rewire the engines. These are Caterpillar engines. They're taking the old control panels, the engine mounted control panels. They're removing them and replacing them with current control panels. But that changes a lot of the interfacing for the controls. So we need to coordinate this to be sure that our controls will interface and work properly with the new engines and gensets after they are upgraded. And then from there, of course, we'll do the design and the manufacture and test the retrofit and the components and the design. Then when we're ready to ship, we coordinate with the contractor to remove, existing components and install the new retrofit components, which again, it pretty much is doors and sub pans. Sometimes our own field commissioning team, sometimes they will go out and do the change of the doors and sub pans. But we need to coordinate the commissioning with the customer. Sometimes that requires them scheduling things, sometimes especially at hospitals and things like that, installations like that, it's not unusual to do a startup at 3 o'clock in the morning, so this has to be coordinated with the customer. And then lastly, when it's all said and done and we're finished, we need to be sure that we provide the customer with the proper documentation, which is as-built drawings, other documentation, PLC programs. If sequence of operations have changed, we need to be sure that we provide them with the written documentation that reflects what was done there, and that kind of finishes up the step-by-step processes. Okay. Now here's an old piece of switchgear that we retrofitted. This originally was installed, this was at a hospital here, actually locally. The switchgear was installed in the late 80s, and you can see conventional switchboard meters. You can see all the little indicator lights, and there was a lot of them. And you see all the switches and everything. And we upgraded the controls. We put in new doors and sub pans, left the power envelope pretty much intact. And then the next slide, you'll see what it looks like today. And there it is. And you notice meters are gone, the lights are gone. You see just a few switches there. All the controls now are incorporated on that touchscreen. And they actually took out the old gensets, and they actually put in newer gensets. So they'd increased the kW on them a little bit. But you can see how much of a change the upgrade did to the switchgear, and it works perfect. Okay. Here's a picture of what I talked about earlier about replacing um, doors and subpans. This is a subpan. And just to give you a brief little example about integrating the functionality of these devices, there on the left, the original, you'll see on the left red circle, that's a conventional Woodward governor. Next to it is a conventional Woodward synchronizer. Could you buy a synchronizer today if you needed one? Yeah, probably Woodward would, but I guarantee you it'd be built to order, and the cost would be very, very expensive. So, but today, if you notice there on the right, that's a Woodward, what they call an Easy Gen, and it incorporates all the functionality of synchronizing, load control, load sharing, and it has communications. The older governors, they didn't have communications, so you really couldn't interface that into anything for monitoring. Whereas the new products there on the right side, um, that's what communicates to the PLC and displays all the engine information on the touchscreen. So we don't need all these indicator lights, and you can see the fewer components there on the right compared to what was originally on that subpan, which again, fewer components, much improved reliability. Okay. Here, this is another retrofit that we did. There on the left side, you see the original. This was some medium voltage switchgear. And again, when we upgraded it, pretty much the power envelope itself was intact, and we replaced the doors. And you can see there on the right how fewer components there are on these doors. Most everything was integrated into the touchscreen. You see we have new protective relays. Those are the devices there with the yellow stickers on them. Those protective relays, they have communications. So we can display all that information on the touchscreen versus before the original, it just wasn't possible to do that. And again, we have much fewer components, much greater reliability. Okay. Here again, another retrofit that we did. You notice there on the left, this is some 90s vintage switchgear. And as I'd mentioned earlier, you can see there on the left, that keypad. That's just a numeric keypad. Label above it told you what the settings were. And then you see the indicator lights, a multifunction digital display there on the top. And after we put a new door on it, you can see you got a touchscreen, a few lights, and that was about it. Everything else was integrated into the much fewer components that's on the subpan. Okay. As I'd mentioned earlier, we do retrofit other manufacturers' equipment. This was a retrofit there on the left. That was original Point 8, which was a manufacturer, I think, down in Louisiana. And you can see that multi-window annunciator. That's a lot of wiring. You see the meters, a lot of wiring on the meters, and look at all the switches. And then you go over there on the right side, and this was after the retrofit. That's a Woodward Easy Gen remote panel. It's got a little colored touchscreen, and you got membrane buttons for the switches and controls, and then down below you got an emergency stop push button, a circuit breaker switch, and position lights, and that's about it. So again, I mean, it kind of gives you an idea of how much wiring has been reduced after the upgrade and the retrofit. Okay.
All right, Steve. Well, Thanks a lot. A lot of wealth of information. And it looks like I have 1, 2, 3, 4, 5, 6 questions that we'll try to get through during the session, but it looks like we have plenty of time to do so. So I just want to remind everybody, if you do have a question, it's still not too late. So just click that Q&A tab and send us your question, and we'll get Steve to answer them. We want to make sure that we take advantage of his close to 40 years of experience. So I'm sure all questions to him based on his experience are softball questions. So I know he's ready. So with that, let's get to the first question. So Steve, you were talking about power envelopes, and the viewer wants to know, what do you mean exactly by power envelope versus controls?
Okay, very good question. We refer to the power envelope, that's the switchgear itself. And when we talk whether low voltage or medium voltage, and I use medium voltage for example, the power envelope, that's the circuit breakers, that's the main bus, the risers from the breakers up to the bus, the potential and the current transformers. That's what we mean when we say the power envelope. That is purchased as a component, but generally breakers, you don't have to replace breakers, you don't have to replace bus, you don't have to replace PT and CTs. You may or may not want to upgrade the protective relays depending on the vintage. But if there's ample room in the power envelope, generally there is. It's typical, we'll have a utility breakers, generator breakers. Normally there's room on the doors, on the upper doors. Again, the breakers are at the bottom, but usually there's room on the upper doors to put the controls. The sub pans usually have ample room to mount components. But some customers, some installations, they want the controls totally separate. And some of these upgrades that we do, I know presently we're doing one, as I'd mentioned earlier, about the pharmaceutical out west. The existing switchgear, these are 5 kV generators. We're not touching the switchgear or the power envelope as we refer to it. We're just going to replace the controls. So as again, sometimes the controls are totally separate in a separate control panel lineup. And sometimes the controls are incorporated in the power envelope, as you will, or the switchgear. You can always, power envelope refers to the switchgear. Okay.
Okay. And then this is a question coming in that kind of relates to this one as well. Were the MV circuit breakers replaced as well?
No, they were not. Generally, the breakers are new enough. We've been using vacuum circuit breakers for years and years. And especially, if you have a system, as long as the circuit breaker doesn't trip on like overcurrent or things like that, especially with the control systems today, with the loading controls and things like that, generally breakers aren't open or closed a lot of times with hardly any current going through them. So breakers tend to really last a lot longer than the components, and breakers, they generally don't tend to become obsolete like some of the other components. Yeah, that's a good question.
Okay. All right. Let's see. The third question is, why can't you just take the existing doors and modify them with cover plates for components that were removed rather than doing a completely new doors?
Well, first of all, sheet metal is relatively inexpensive. So to purchase a new door, you're going to add very little cost. But if we were to just remove components and put cover plates, this is something that would have to be done at site. We would have to do all the wiring at site, which would make it a lot more difficult to assure proper testing. And again, as I said, the price of sheet metal, we would just have our shop personnel wire up the components, mount the components. You saw in the illustrations how clean some of these panels looked. And if you can envision in your mind all these components and switches and things like that, if you just put individual little cover plates aesthetically, it wouldn't look good at all. And plus, as I said, the issue about testing, you know, when after our shop personnel wire the doors and everything, they go to test bay and they are tested thoroughly. They're interconnected, the subpans and doors, that's part of the manufacturing, is to do the interconnects, and makes it a lot faster on site, just to take out old subpans, put in new ones, take off old doors and put in new ones. And that's typically why we would prefer to do the retrofitting the way we're presently doing it.
Okay, Steve, and that kind of segues into the next question, because it deals with testing as well. So they just want to know, you know, they want more information on how controls are tested before they are shipped to a job site.
Yeah, the controls, because, you know, as I mentioned, we don't have the power envelope, you know, whether it's a separate control system or we're going to replace the controls on an existing power envelope. We're not going to have the circuit breakers. We're not going to have the current and potential transformers and things like that. But we do, that's all simulated. And, you know, we'll simulate the breakers. We have PLCs down in our testing department that are used for a lot of this simulation, and it allows us to essentially fully test the system. You know, I mentioned earlier about sequence of operations and things like that. We can write a little test program, put in a PLC, and use that PLC, you know, to act like what's really out there, and we can fully functionally test these retrofit systems when they're complete.
Okay. All right. Our next question is, how do you reevaluate short circuit withstand rating on retrofitted equipment?
Well, yeah, that's a good question too, because especially, you know, if you have existing generators, for example, that parallel with existing utilities, usually that's not going to require things to change as far as breaker ratings and things like that. But we have done systems where a customer has had, say, for example, existing generators that presently don't parallel with utility. And then all of a sudden he says, like, well, you know, we're going to rewrite this contract with the utility and they're going to allow us to peak shave. Well, right then and there, and that is a very good question, because a lot of people tend to forget that. But when you all of a sudden now you're going to parallel with utility, that means fault current availability can increase. So you definitely have to be aware of that. And sometimes you may have to take, you know, for example, maybe your breakers are rated for 65 kA interrupting. And now your available fault current goes up. And yeah, sometimes you may have to take out, and sometimes that will require replacing the gear, because it's not just the circuit breakers that has to be able to withstand increase fault current availability, but you've also got the bus rating. The bus has to be able to withstand. So absolutely, that has to be reevaluated, and that is a very good question.
Okay, interesting. So do you also certify the control panel for UL 508?
Yes, we do. Yes, we do. And that would, of course, that would be a 508 listing. It wouldn't be 1558 or 891 or a medium voltage certification because we're not changing the breaker itself. But yes, we do actually UL list controls 508A.
Okay. And we're coming up on the last question that was submitted, but we do still have time. So again, if you have a question, go ahead and submit it. So after I ask this question, I'll look in the tab to see if there's any more to go through. This happens to be our first question via text. Technology these days. So let's see here. So if a facility is being updated with a new Cicada system, and for those not familiar with Cicada, system control and data acquisition system, or a remote control and monitoring system, is it better to replace or retrofit the switchgear and controls?
Well, a lot of times the SCADA, and for those that aren't familiar, SCADA essentially stands for System Control and Data Acquisition. And you usually find very elaborate SCADA systems like a water treatment facilities and, installations like that, for example. And yeah, a lot of times that will also have to be upgraded. Sometimes they might consider totally replacing it because, again, a lot of these newer devices and components these days, because of the technology, I'd mentioned earlier about protocols changing, and if their SCADA system, it may operate with protocols that are not current. A lot of times the components, just because of the communications capabilities that they have now, they may not even exist in their existing system. So yes, a lot of times the SCADA system will also have to be either upgraded and or replaced totally. Yeah.
Okay. All right, Steve, thank you. And we've cleared the board with questions. So I am going to wrap up the Q&A session. Oh, wait, hold on a second. One just popped in. Let me read it real quick. Okay, so are there any issues with integrating an old switchgear system when adding it to a microgrid system?
Not really. As long as you understand what's existing, and that's the big thing. But generally, no, that's not an issue because especially with the integration that's done today and the way the technology is, that's usually not an issue.
Okay. All right, so thanks for that question. And I'm going to wait. I'm going to keep it on this slide for about 30 seconds or so and just talk. So if you have any more questions, feel free to ask them now. But upon conclusion of this webinar, say that 3 times fast. So upon conclusion of this webinar, you're going to receive a shareable download link. So you can view it, like if you missed something or you join us late or anything like that, you can go back and look at the webinar, pause it, or whatever you want to do to make sure that you capture the information that you wanted to receive out of this. Also, it's a shareable link, so feel free to share it with your peers, your teammates, and whatnot. It's just spread the information because all we're trying to do here at Enercon is just share our knowledge on specific things so that you are well informed of not only our capabilities, but some capabilities that you may want to obtain or some needs that you may have out there that you want to have addressed. So basically, we are here for you as your power generation expert. And I do have a question specifically for you, Steve, as far as will Steve be involved with your retrofit team?
Yeah. Yes, I do get involved. My role As applications engineer, I work very closely with our sales department, and we've got presently we have two retrofit projects going on. One of them is the big one, the pharmaceutical out west, which is retrofitting our own controls. And then another retrofit we're doing in Arizona. We're retrofitting some existing GE Zenith controls. And that one, it's medium voltage, and we don't need to modify or change anything in the power envelope or the switchgear, because that system, when it was built, it has some controls only sections in the lineup. So that's all we're going to have to do is to replace the doors and subpans on those three control sections. And one of them is the master control. And then the two sections are for the generator controls. But yes, I do work closely with the sales department on retrofits.
Awesome. And with that, I see no more Q&A. So thanks again, Steve, for sharing your expertise. I know you've been around the block many a times, and your knowledge is invaluable to the team as well as the whole power generation community. So I want to thank you for that and your 40 years of unwavering service to this industry. So,
well, thank you, Sean. I appreciate that.
Yeah. So with that, audience, I have good news and I have bad news. So the bad news is this is our last webinar of 2020. So that's the bad news. But the good news is we're already planning a new webinar series for 2021. And if you're not familiar, we did start this in 20. So this is, again, this is our sixth webinar, like I mentioned up top at the beginning of this webinar. And we had a lot of positive feedback and response to us doing this. So we plan on doing another series of webinars in 2021. So stay tuned to what we're doing. And so how can you stay plugged in to Enercon and what we're doing? We have various different social media platforms. So if you go and you subscribe to YouTube, for example, subscribe to our page, like the page, and then you'll automatically get updates whenever we post the updates to the YouTube page or to Facebook, for example. Those are our two main pages there. And if you want to send in a question or to get more information about Enercon, like a capabilities brief or something like that, send me an email or shoot me a note, or go to the Enercon webpage and go there and just click the info button for more information and type in what it is that you would like to know, and then we'll get you an answer as quickly as we can. So I want to just thank you all for joining us. Thank you for staying plugged in. So on the behalf of the entire Enercon engineering family, we just want to wish you a very safe and as can be 2020, and stay close and finish out the year strong. Thank you for what you guys are doing, and this concludes the webinar. Thank you.